Welcome back. This is an Aleks training video on finding the conjugate of an acid or a base. An acid is a proton donor, and a proton is a hydrogen cation or a hydrogen ion, H plus. And so if something is an acid, it has a proton to donate. It has an H plus to donate. Almost all cases, acids are hydrogen something. So it normally begins with H and then has something else. When that molecule donates the proton, whatever is left over after it donates is the conjugate base to that acid, or it's just its conjugate. Okay? It's its conjugate base of that acid. I think of it like a baseball game. You're throwing catch. I have the ball is a proton. If I have the ball, then I'm an acid. If I throw you the ball and you accept that ball, then you must be a base. A base is a receiver of a proton. So if I am an acid and I throw the ball, so I have lost one proton, then I could catch that ball again. So I'm a base. So if I have an acid to give, I have a proton to give, and I donate it away, then now I am whatever I am without that proton is the conjugate base, and then I could receive that proton again. So it's simple. This you'll find this very easy. What you're going to do is look at the acid, know that it's the hydrogen that's going to be gone, and it's going to be donated. Whatever is left after you take away an H plus is the conjugate base. Now in the case of this first acid, I have two H's to give. Don't worry about two, just think of it as only one. You're actually going to see that this is going to do it twice, but just do it the first time. When I have sulfuric acid, H2SO4, what's going to be left over after I give away an H plus? All right, well, I know that if I give away an H, then it's going to be, I'll be left with HSO4. But what about the plus? Like if I lose a plus, and it's neutral to start with, and I take away a positive, do you see that that's going to leave a negative? Okay, that positive plus that negative made it neutral. I take away the positive, it leaves a negative. All right, so the acid H2SO4, after donating a hydrogen, is going to leave HSO4. So sulfuric acid, the conjugate base is hydrogen sulfate. Okay, what about ammonium? Now ammonium is not neutral, it's NH4. Well, good, I take an H away, that's going to leave NH3, and I've taken the positive away, so I don't have to have a charge there because the original was charged. Okay, what about H2O? Okay, H2O, I'm going to take an H away, that leaves OH, and I take away a plus also because it's a hydrogen positive. That means since it was neutral, this must be negative. So the conjugate base of water is a hydroxide ion. Okay, what about bases? What is the conjugate acid of a base? A base is a catcher of the ball. Okay, so if I receive a proton, I become an acid. So what is the acid I become if I take on an H plus? Well, I start here knowing that that's NH3, so I need one more H. So I'm going to say that has to be NH4. Now it's originally neutral. I add one positive, and so this has to be NH4 plus. All right, so hydrogen carbonate or bicarbonate, it's a negative. So when I add the positive, it's going to go neutral, and I have to add another hydrogen. So this is going to be H2CO3, okay, which is carbonic acid. And then the last one, OH, right? We already saw that water lost a a proton and became hydroxide. Well, this is the hydroxide. So what's it going to be? The positive is going to make the negative neutral, so there won't be a charge. And I need an extra H, so I'm going to have two H's and an O, and that's water. So the conjugate acid of hydroxide is water. The conjugate base of water is hydroxide. Right? So it's kind of an opposite. I think this is pretty simple. You'll get it.